So hello everybody. I'm back again, and I want to discuss chapter 12, and we're going to talk about refinements in capital budgeting. And let me just go back a couple slides here, and you'll see the name of this title is Risk and Refinements in Capital Budgeting. We're on chapter 12 now, and so basically we've assumed throughout the first 12 chapters that all investment projects have the same level of risk, right? No matter what project the company does, the risk is the same. That they're all equally risky, and accepting any project makes the risk the same. It doesn't change it. And that's not the truth, right? That's not the case. Sometimes you do a project and they're not as equally risky and they have more risk. Let's say, Amazon, they try to do a couple things, right? Amazon tries to sell food and it's not working as well as maybe they thought. Well, Amazon came out with a phone a while back, right? And it turned out to be riskier than they thought. So Amazon tries a lot of things, and some projects are more riskier than others, right? And even Apple does some stuff and it's riskier. All right, so here is a table from earlier, all right? And here's two projects, A and B, and you invest $42,000 in this one and $45,000 in B. And here's the cash flows associated with them. And if you're not familiar with net present value, which is the calculation they do here from, I believe it's from chapter 9 or 10, you can go back and review that in the Getting book, which you have online. Okay, so here's the net present value. And if you remember, the fact that both of these are positive means that the projects are worth doing. All right, so I'll jump ahead a little bit here. And here was the equation for net present value. Right, so this is the closed form equation for net present value. And here's the cash flows, and this is your required return, and you pop that in there, and this is the number of years. So this would be 15 years, right? 15 years, and 10% would be R, right? And here's the initial cash flow of 10,000. So if you pop this either into a financial calculator or you can use Microsoft Excel here, if you have any questions about trying, here's the way you pop it into Excel. You'll notice that that basically there's a break-even period here. That this is the payment. The break-even, you'll notice that they're calculating the payment to find out when exactly they'll break even on their initial $10,000 investment. So if they make a payment, they receive a payment of $13,000 a year, right, for 15 years, they will break even on that payment. So that's basically this equation here using a calculator. Okay, so for either project to be acceptable, the net present value must be, as we said, greater than 0, all right? All right, so for the projects to be acceptable, they must have, as we just showed, annual cash flows of at least $1,315. And basically, you can see here that there is a statistical approach. And here's that they're just doing an assumption, right? Assume, that word is important, that a statistical analysis results in the following. Probability of getting 1,315 for project A is 100%, and the probability for B is 65%. All right, so it appears that this is less risky because there's a 100% guarantee, right, than this one. So here's another example, right? Here's another example of a similar thing. And you have two projects, again, A and B. You both have initial investments of 10%. And here are the cash flows. And here are the net present values associated with the cash flows, right? So this is the range. Here is the range of cash flows, you can see the difference between this number and that number, right? 9,000 and 1409 should be 7606, and the range between this number and that number should be again 30,000, because this is negative, right? So so they show you the net present values of both, even though they're positive. Okay, this one here has a lower range of net present values, and the range of the actual cash flows are the difference between that and that, right? The high and the low, right? And the difference between the 4,000 and the 0 is that 4,000. All right, so. All right, so they're talking about simulation. This is just a discussion about doing a simulation on and net present value simulation and doing mathematical models. All right, so I'm going to jump ahead. You can read up on this type of stuff. There's no equations or math here. Different types of risk, right? If you invest in countries that have shaky governments, you'll have to worry about like political risk, right? It's much harder to protect against, like you had the Arab Spring, remember that? And countries have problems like Syria, and you don't want to probably invest in those countries, right? All right. So this was the net present value again that we're looking at. Here's the equation for net present value, and the only difference is we take the return that we had previously, and we now put risk-adjusted discount rates. So all we're doing is taking the exact same equation and just putting the different risk levels for each project. That's it. If you have any questions at any point, you could email me. And again, as I sent you an email about, sometimes these homework problems have bugs, so don't worry too much about that. And I'll take care of that. All right. So here's a personal finance example of investing in two stocks, A or B, and because stock B can be sold to net 1,500 here, stock A can be sold for 1,200, and she makes the following calculations to find the risk-adjusted net present values, and they give you different average risk stocks, right? Return on average risk stock of 11%. Because stock B is considerably riskier, she will require a 14% return. So one's 11 and one's 14. So you're calculating the risk, the net present value, right? So here's the net present value for A. You notice this one's got 11%, right? And this one's more risky. It's 14%. So although Taylor's calculations indicate that both stock investments are positive, they're both acceptable. On a risk-adjusted basis, she would invest in stock B because it has a high net present value. All right, so we talked about the capital asset pricing model in Business 330. If you didn't take it, go back, I believe, to maybe chapter 7 or 8 or something. But, search and look in the textbook for capital asset pricing model. And total risk on anything in general is, for stocks, let's say, is non-diversifiable and plus the diversifiable risk. Okay, so the diversifiable risk is what you can get rid of by investing in a lot of stock or a lot of something, right? You always hear them say, don't put all your eggs in one basket. You're diversified. Okay, non-diversifiable is things that happen in the economy that you have no control over, right? So no matter how many stocks you have, things may happen that may cause the stock market to tumble. For instance, September 11, 2001, when we were attacked, no matter how many stocks you had, right, you were going to take a huge loss in the market because all the stocks went down. It was a terrible event, right? And the non-diversifiable risk we talk about is how much risk you do take. I'll use a term called beta, and every stock has a beta, okay? And we talked about beta in Business 330, so you should go back and review about what beta is. Before anybody buys a stock in real life, they should look at what the beta is. It tells you how volatile that stock is, right? It's an index of the degree of movement of an asset's return in response to a change in the market's return. All right, so here's the equation for the capital asset pricing model, which we earlier saw in Business 330. And again, you can go back and review that. And here's the beta, right, telling you what the your return is on that, on a particular stock, right? It's the required return on asset J, and it's a function of the beta coefficient. This is the market return, and RF is the risk-free rate in the economy. Typically, that's a treasury bill rate. All right, so figure 12.2 shows two projects, L and R. Project L has a beta BL and generates an internal rate of return. And a lot of these terms we previously discussed. You'll have to go back to chapter 10. All right, the required return for a project with risk BL is RL. And here's all the details on project R, and here's the details on project L. All right. So if we if we go back and look, and here is the security market line, and you'll notice you accept any project, right, above this line, right? The net present value is greater than 0, right? Here's the beta of the market. The beta of the market is always 1. That would be the S&P 500, right? So the beta is always 1, and right here's the beta for investment R, and here's the beta for investment L, right? And you'll notice the internal rate of return here is greater than for L, and here's the internal rate of return for R. So anything below the line you reject, and anything above this line you accept. It's that simple. If you look at the security market line, this line, this blue line, is simply this equation right here. And let me go back. Graph. They graph that line, okay, for different betas. That's all they're doing. All right, so I'll cut it off here, and I'll send more on this. We're almost 15 minutes into this. All right, so we'll pick up. We will pick up on on slide 27. All right, I hope everybody has a good day.